Okay, so it says if f of x is a polynomial function, you can write it out like that. And all that that's saying is that, you know, when we write these polynomials, long polynomials like 3x to the 5th plus 2x to the 4th, that we usually go in descending order of exponents, right? So we start with like 5, then we would go to 4, then to 3, then to 2, then to 1, then to 0. Okay, so it just all that it's saying is that's the order that we typically write polynomials in. And you guys know that, okay? Where n is a non-negative integer and a to the n does not equal 0. That just means that we are starting with something and it's not just a constant.
Why is there an ellipses?
Why is there an ellipses?
Like
Oh, the dot, dot, dot. So because it basically is could say, you can't use those big words with me. I don't know what you mean. I thought you were talking about an ellipse, like the oval. I was like, what do you mean? Okay, that's an English term. I don't do English terms. No, I got that one though. That was good, right? See, I know some of this. No, all that it's saying is that you could start with like an n of 25, right? And so depending on how many you need to get all the way down to x is equal, like to x to the first, right? So you could have a degree polynomial of 52, or you could have a degree of 4, right? So it just kind of depends on the number. All right, so let's talk about roots of the equations. A root of an equation is a number r, which when substituted for x leads to a true statement. So basically, it is something that makes it equal to 0, right? Other names for root. What are other things that we call a root? What's another word I could use for root? You guys know this.
Zero.
A zero, yeah, we call them the zeros of the equation. Oh, like the zeros, the roots, the solutions. I like that word. If we're graphing it, where do these fall? These are your x-intercepts, right? They're your x-intercepts, they're your zeros, they're your solutions, okay? All those words just mean roots. So if I say find the roots, right, you could be going back to any of those terms, all right? So I look at example 1 as -3, a 0. Now notice I use the word 0 here, but I use the word root here. It's the same thing. It's just asking, is it a solution? Does it work, right? So just think of the word solution. Does it make that a true statement? Well, how would I test if that's a 0 or a true statement? Plug it in. You're exactly right. So I would take -3, right, and I would plug it in here. And so I would do f of -3, and I get -3 to the 4th, and you'd use your calculator. And what would you get? Right? What is that? 81 plus 9 minus 6. So we get 84. So if I get 84, is that a solution or is that a root? No. What is it supposed to equal if it's a solution? Yeah, it's got to equal 0, right, when I plug it in. So I would say no, it's not, because that does not equal 0. Okay? Try the next one. Is square root of 2 a root of that equation?
Yes.
Yeah, does it work?
Yeah.
Okay.
6 plus.
Yeah, you have square root of 2 to the 4th plus square root of 2 squared minus 6. And so you'd have,
4 plus 2 minus 6.
right? So this would be 4 plus 2 minus 6. And so since it does equal 0, we would say yes. Does that make sense? Okay, so you guys know how to do this. It's just, again, using this terminology: zeros, roots, solutions, x-intercepts, etc. All right, when it's written in factored form, this is really easy. What are my 3 roots of that next equation there?
0.
Yep.
1.
0, -1, and positive, oh, -1. Sorry, -1. They're both negative, right? So this is x equals 0, x equals -1, and x equals -1, right? Well, that -1 is repeated, and so we have a name for that. It's called a double root, okay? Or we can say that it has a multiplicity of 2. So this word multiplicity, you're going to hear a little bit this section. If a root is repeated k times, we say that it has a multiplicity of k, right? So if it's like something to the 3rd power, with me? Yeah. Julie. You're just responding to her. Okay. If it's repeated a certain number of times, we call that its multiplicity, okay? So multiplicity of 3, multiplicity of whatever. So state the multiplicity of each equation, or each root. So what's this first root? So the root is 4. What is its multiplicity? Yeah, 2 is just the exponent. Okay? Same thing for this one. What's the root? 5. And what's its multiplicity?
3.
Perfect. So that's pretty easy. Okay? Multiplicity, and you've probably heard this before. Okay? So that should be review. All right, so it's kind of cool theorem called the remainder theorem. And what the remainder theorem says is that if we take a polynomial and we divide it by x minus r, your remainder that you get, and this is all synthetic division here, right? So if I divide something, and the easiest way is going to be to use synthetic division, and I look for whatever I get as my remainder, that remainder is always equal to the value of the function at that value r, right? So if I were to take the r and plug it into the actual equation, I would get the same thing, and I'll show it to you in this example. So let's first use synthetic division to find that remainder when I'm dividing by x minus 1. So when we do synthetic, we talked about this yesterday, I divide by the root, which is equal to positive 1. So I take 1, I do my synthetic division. Do I have any placeholders here? No. All right, go ahead and do synthetic division. 2 times 1, add negative 1, negative 1, 3. So what's my remainder? 3, right? Yeah. I was like, wait, what did you say? Okay, so remainder equals 3. Now what the remainder theorem says is that should be the value of the function when I take that root 1 and I plug it into my function. I should get the exact same thing. Well, let's check it out and see if it's actually true. So what is f of 1? Well, I plug it in here. I get 2 times 1 squared minus 3 times 1 plus 4. And so f of 1 is just, yeah, when I work it out, 2 minus 3 plus 4, and I end up getting 3. And it does work. Okay? It'll work every time. Okay, so why? Sorry, what's the point? Like, you think that's cool. I think it's kind of boring, right? Why is this exciting? Right? What's exciting about this is sometimes when you have a number here, right, and you're trying to plug it in and work this whole thing out, this could be a lot of work, right? If it's like negative 7 or something, and you have to plug that in, you have to square it, multiply it by 2, and then minus 3 times negative 7 plus 4, right? Or like negative 22 or something crazy. Doing a synthetic division real quickly and just finding that remainder is actually going to be a lot easier and a lot quicker in a lot of situations rather than doing it like this, okay? The other reason this is really important is because what if my remainder is 0? The remainder is 0, then this is equal to 0, which means that that is actually a root or a solution or a 0 of my function, right? And that's pretty cool because we want to be able to find those roots or those solutions really quickly. So the big deal here is if we get that remainder of 0, yay, we've got a root. Okay, that's kind of our big deal, right? All right, so let's see what we can do. Find f of 3. So this is kind of the same idea here, but we're going to do this backwards. So again, we kind of got to do this the long way. We plug it in. Right. And then this is like, okay, wait, I got to do, you have calculators, so you can work this out, right? But 27 times 2, what do you guys get? Minus times 9, right? Plus 3 minus 6. Did I get 6? What'd you get? 6, yeah, all right. I think you should get 6. Yeah? So f of 3 equals 6, right? But what we can do here is use remainder theorem instead of actually plugging it in. So now instead of plugging it in, I'm just going to go over here, right? And take that 3 and do synthetic division. 2, negative 5, 1, negative 6, 2, 6, 1. What did I do wrong? 12. No, I didn't. I got it. 6. Good? So notice again, I get the same thing. Which of those do you think is easier? Synthetic? Yeah, right? I mean, synthetic's pretty quick, especially with these kind of numbers. And you're going to get the same answer. So again, that remainder is going to be the same. It says use remainder theorem to determine whether it is a factor. This is another word we can use. If it's a factor, remainder should be 0. So is this a factor? No. Right? Because remainder doesn't equal 0. Okay? So that's another way to say it. If it's a factor of it, or if it's a solution or a root or whatever. And that's all that this next factor theorem says. So f of x is a polynomial if that function is equal to 0, or if remainder, that's all this is saying, equals 0. Then x minus r is a factor. Okay? All right, let's look at a graph. X cubed minus 2x plus 1. So let's graph it on our calculators. Ooh, I'm still in polar mode. Okay, let's get out of polar mode. All right, so I'm going to graph x cubed minus 2x plus 1. All right, it says use your calculator to find the zeros. So what's happening in here? Are we clear? I'm kind of not clear. What should I do to figure out what's really happening in there?
Zoom?
Yeah, I could do some zoom in, right? So if I zoom in a little bit, ooh, we notice, see that little dip right below there? So it is actually dipping below. So how many solutions does this have, or how many zeros? Yeah, it looks like it should have 1, 2, 3. All right, so I can just do sort of a little sketch here. All right, and so there's 1 here, 1 here, and 1 here. And we can find those zeros. Remember how to do this on your calculator? Second calc, number 2 is 0. And then it asks me for left bound, right bound. Okay, because these are obviously not exact. All right, and so I got for my zeros, x equals negative 1.618, and then we can do the other ones. You guys get the idea. Keep going. And my other one is 0.618. And then what's the last one? We got it yet? Left bound, right bound. Ooh, that one's nice. Okay. So it asked me to find the zeros. So on my calculator, I can obviously find my zeros. But then what we want to do is go to 6a here, which actually should be like 5b. And we're looking at that same function that we just looked at. Okay. X cubed minus 2x plus 1. And since we found one of them to be 1, right, to give me an exact answer, these other two are decimals. What I'm going to try and find is what are the exact answer solutions for these other two, okay? So since I know one of the roots is x equals 1, I can just do synthetic division. Since I know that's a factor, I can use synthetic division to simplify here. So what I'm going to do is use synthetic division with that root of 1. Okay, x cubed, so this is 1. I have a 0 in there for the x squared term, minus 2 plus 1. Do your synthetic division. Negative 2 plus 1 is negative 1. And look, oh yes, we knew that already, right? We have a remainder of 0 because it is a factor, it is a solution. That's what we were just told. So that's obvious that we have that. So now this remaining stuff, this is x squared, right? So I have x squared plus 1x minus 1. So what that's saying, and we can rewrite this kind of like we did yesterday, right? We can take the original equation, and it's saying now I can break it up into the factor of x minus 1 times this quotient, right, which is x squared plus x minus 1. Does that make sense? I mean, what it's saying is that if I multiply these two together, it's going to equal that. This is a factor of it, so I can write it in factored form. And the remainder is 0, so it would be like plus 0 here. I don't have to write the plus 0 because my remainder is 0. So this is just what we did yesterday with product equals divisor times quotient plus ratio. Or sorry, plus remainder, right? My video. Hold on. Don't stop, don't stop, don't stop. All right, we're still going. Okay, so now I'm like, okay, well, that's great, but what does that help me with? I still want to figure out my other two solutions. So I know one of my solutions was x equals 1. Well, yeah, we already figured that out by the graph. But the other two now, I just need to solve this. Does this factor? No. So what do I have to do to solve it? X equals opposite b plus or minus square root b squared minus 4ac all over 2a. La 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 la. What do you get? Square root of 5. Is that right? And ta-da, let's check to see how good we are. What did we have? Negative 1.618 and 0.618. So let's just check those. Negative 1 plus the square root of 5, all divided by 2. Oh, look at that. There's our first answer. Looks good. And then our second one, negative 1 minus the square root of 5, all divided by 2. Oh, look at that. There's our other one. Okay, so it did work out. So a lot of times I'm going to ask you guys to find exact solutions. And this is a cubic, right? So to find an exact solution of a cubic that doesn't factor, we've never been able to do that before, right? Never. So one way to start it off would be to graph it, get one of the solutions that's exact, you hope, okay? Use that exact one to then do synthetic division and then figure out the other two, okay? Question. Solomon, I heard a question.
Yeah. So would we, like on a quiz or like on our homework,
Yep.
would we write the answer